Okay, my name's Michael Musa. I'm going to be talking about job queues with Gearman. The link to the GitHub link here on the bottom is going to have all the sample code and slides and this recording if it comes out all right. And this is a joined-in link for this talk. If you end up liking the talk, don't like the talk, please post feedback so I can improve it or continue doing whatever it is I did well. Just a brief about me. I've been a PHP developer for about 15 years now, starting off with a short time in PHP 3 and then on to 4 and 5. I'm currently lead developer at the XAM network. We make websites for games like League of Legends, World of Warcraft, and a recently released game called Destiny. And I'm also a Zen certified PHP engineer and ZF2 architect. So tonight, basically we're going to be talking about what Gearman is, why we should bother adding that to our application, how to get started with Gearman, an overview of the PHP API. Throughout the talk I'll be showing a lot of examples, and then we'll go briefly into unit testing at the end. So the dictionary definition of Gearman is that it's a generic application framework to farm out work to multiple machines or processes. And that's straight from the PHP manual. But what does that really mean? So let's say we have a web application that's running our website, or sorry, a web server that's running our website, and that website needs to do some amount of work that is probably not best to do on the site, because we don't want to keep our users waiting, or because it's very CPU intensive or memory intensive. That web server can put a job request in a Gearman queue saying, hey, I need this work to be done. That Gearman queue will find a Gearman worker process that will do the work, and that work could involve talking to an external API, could involve reading and writing from a database, or doing anything else such as image processing or whatever it is your application needs. The worker will report back that it's done and could give a status message, and the server will report back to the web server. Sorry. So this last part, the communication from the worker back to the server is kind of optional. You can send jobs in the background, you can send them in the foreground and not send a response, because maybe you just need the work done, but you don't necessarily need to communicate back what happened. But the first part is typically part of what you need to do. Send the job, get it done, and then move on. So that's real nice, but what exactly are we trying to do by implementing this? We don't want to just implement this new technology just to have it. It should suit a particular purpose. So I'm going to do a few demos. This is going to be our demo site, which doesn't load for whatever reason. Well, that's okay. That's not terribly important. This is just the Bootstrap template when you download from Bootstrap the basic default. And what I've got is a few demo applications. So demo 1 is just a baseline script that's going to give us an example of throughput from our web server on a trivial page. All it's doing is displaying the template file from Bootstrap. To do that, I'm going to use Apache Bench, which is just going to send a total of 10,000 requests to this page with 250 of them at a time. And if we run that, and I'm also going to start the top up here, this will just give us an idea of what the server is doing as far as CPU and processes that are running and memory usage and such. So if I run that, you'll see that it's getting through the request fairly quickly. We don't see a whole ton of CPU being consumed. We're only using about 13% of the CPU available to this virtual machine. And it's just going to go right through. And so we ended up with about 600 requests per second and an average of 416 milliseconds for each request. And CPU of 13%. So keep those values in mind when we look at example number 2. Number 2 is the same exact thing as example number 1, but we have this extra step right here at the end called do expensive thing, and all this is going to do is simulate the CPU being used to do some real kind of work for between 1 and 3 seconds, depending on what this random number is. This could represent anything from image processing or searching through large files or just anything that's going to need a lot of CPU time that we don't necessarily want our web server to be doing. So if I run that instead, you're going to see much different results. The first time that I ran this completed 1,000 requests, showed up fairly quickly. We're still waiting here. If we look at the process list, we're going to see that there are a ton of Apache children waiting, and the CPU is at 100%. So this web server is doing pretty much all it can do. It can't do any more. And for those of you familiar with load average, we see a load average of close to 40 here. And so on a VM with only 1 core, that's very bad. So if I kill that, because we're not going to sit around and wait for all 10,000 requests, you'll see that the performance dropped to 44 requests per second instead of the 600 that we had before, and the time per request is growing larger and larger. We're up to about 5 seconds here after everything that we're doing, and again the CPU is at 100%. And that's going to make your boss and your system administrator very upset, because your site is not going to be able to serve more traffic. You're going to have users waiting between 2, 3, 4, 5 seconds for their pages to come back, and eventually Apache is not going to launch any more processes to serve more traffic, and everybody else is either going to wait or they're going to get an error page. That's very bad. So Gearman can't help us with this, and I'll show you specifically how, but first let's get into initial getting started with Gearman and how to get set up. It's pretty easy to get it up and running on a Ubuntu server. There are a few packages that you need to install. There's Apache, the PHP 5, the CLI, and the dev package, as well as the Gearman job server and the libgearman dev package. That's required by PECL to install the PHP Gearman extension. If you're not running on Ubuntu, there are instructions on gearman.org for other Linux distributions or OS X or Windows. So to talk to Gearman, we use the PHP API. And the PHP API consists of a few classes. There's a Gearman client, a Gearman job, a Gearman task, a worker, and a Gearman exception. So I'll go over each one briefly, and we can get some context as to how all this works. So the Gearman client, its primary responsibility is to connect to the job server and to make requests. So this is what your web server would be using to get work started. So if this is running on our web server, we create the client, we tell it what host and port we're going to be talking to for the Gearman queue, and then we tell it to do some work. In this case, we're sending a request for work to be done at a priority called normal, and this is going to happen in the foreground. So the web server is going to wait for this request to finish and come back before it proceeds. And we're telling it that we want to do some work called foo, and we're passing it this JSON string hello world. The Gearman job is what represents that unit of work that needs to be done, and then is used to talk back to the Gearman queue server. So the Gearman client that we used earlier, and we sent that workload, that's going to appear on our worker as a Gearman job. And here we're able to get the workload. The workload is the parameters that we pass along with it, the hello world, and that's how the worker is going to know what it needs to do with this particular job. And then the worker can send back a response if the client is waiting for one. It could send a complete message to say, hey, I'm done, here's what happened. It could send data intermittently, like if it's something that's going to be communicating back to the client multiple times. It can send a failure, or it can send back an exception. There are a few options, and that's in the PHP manual under the Gearman job for all the different options that you have. There's a Gearman task. The Gearman task is used to receive communication back from the server in a callback. So what we did earlier in the Gearman job, where we send back responses, the client uses callbacks and the responses that appear for the client from the worker come in the form of a Gearman task. So here we have our client from earlier. We're telling it whenever you receive a complete message back from the worker, call this function. And then task is going to contain the data that was sent back from the worker. We have the worker, and this is what actually registers the work functions and does the work with the jobs that you submit to it. So earlier when we used the call to the foo, we receive it here in add function, and then we're telling it that we want to call a function called bar with any jobs that come in under foo. And then the loop on the bottom will just continue listening for work to do and servicing those jobs. And then finally there's the Gearman exception, which we use when something goes horribly wrong, but don't worry about it, that's not going to happen to you. So let's look at a few demos of Gearman in action. So demo 3 is the same thing as the previous demos that we had, except here we are going to use a Gearman client to, instead of do this expensive operation on the web server, we're going to have it done on the Gearman worker. So now if you hadn't noticed, here on the left I've got a virtual machine called web, and on the right I've got a virtual machine called worker. So these are, as far as my little environment here knows, these are two completely separate machines, so they should behave independently. So now if I start up the worker, alright, so that worker is waiting for work now. I'll go ahead and run demo 3. So now you'll see that this is still slow, like the previous one that we did. But look at the CPU. CPU is only at 6%. This site could continue to serve traffic because it's not being, the CPU is not being pegged right now. Load average is really low and there's not a whole lot of memory in use. If you look over here at the worker server, however, you'll see that we're using a lot of CPU. So this server's, it's taking the brunt of all this computing time that's required, and it's letting the web server continue to service jobs. This is a better situation, but it's far from ideal, because if we look at the stats now, instead of, we had 600 requests per second initially, then we dropped to about 40, and now we're getting less than 1 request per second. Quick quiz, does anybody know why I'm only getting 1 request per second here instead of 40 with the previous example? Any guesses?
I had to restart the process for some reason, and now it's back up to speed, but I was wondering the same thing.
Alright, the reason is because on demo 2, the Apache children were all doing that expensive work. Right now the worker is, but I've only got 1 worker.
Right.
So every request that comes in has to wait for that 1 worker to hog the CPU for a second or 3 before returning. So we're going to get a lot less throughput. So what Gearman is a PHP library that it's a framework for offloading work to another server. So if you have a web server that's primary focus is to serve traffic to your users, and it also needs to do something that takes up a lot of CPU time or memory, or it's just very slow, and you don't want your users to sit and wait for that, the Gearman library will let you queue that work and have another server do that work instead of the web server to let.
So use an API to API.
Yeah, basically that. Basically that it's a native to PHP. It compiles in as a PECL extension.
You have to write in your application. You should not have so many applications for it to connect to Gearman.
Right.
Which ones are good to it.
Right. You need to have a Gearman job server running. The Gearman job server is just the queue. That's where the jobs go and they wait for a worker to be assigned to them. And then you need.
This is what is simulating right now.
Yeah. So here on the left, this is the web server, and the demo script that I showed you is what's putting the jobs in the queue.
Right.
And then here on the right, this is the worker that's actually doing the work. let me show you guys the worker. Yeah, so all the worker is doing is it's looking at the workload that came in, and the workload that I give it is just telling you this is how long I need you to hog the CPU. And so it'll take that in, and then it'll hog the CPU for a little bit of time. But the main takeaway here is that this, for all intents and purposes, is a separate machine, and all the CPU time that's being consumed on here is not affecting this server. As far as CPU time, it's affecting it as far as throughput. The web server is not able to serve traffic as fast because we only have one worker, and we're doing all the work in the foreground, but it is a better situation than we had before.
It's not hogging up the whole machine.
Right, so it's not hogging up the whole machine because so this laptop that I'm running this on has 8 cores, and when I created these virtual machines, I told it to give this one only 1 core and to give this one only 1 core. So at worst, these are going to use up only 1/8 of the computing power that I have here. So that was demo 3. Demo 4, I'm going to actually use more than one worker.
Each worker is a web server?
No, the workers are just plain command line PHP scripts. They're not web servers. No, we only have one server, and that's the one on the left. Yes. Mm-hmm.
You could technically write the worker in something other than PHP.
Right.
So if you have applications in Java or C# or Go or anything else,
Mm-hmm.
this is a way for your web application to talk to your back-end applications that may be written in different languages.
Right. Gearman is not something that was invented specifically for PHP. It's common, and there's just a PHP library that lets you talk to it. So you can use this pretty much anywhere.
They have a batch process. You can have it as a worker, and then it comes back when it's done.
Right. All right. So I'm just waiting for all these workers to start up. There are quite a few of them. Okay. So this is all of them. Let me run top again. So I've started up 50 workers. So that same single worker that we had running before, now I have 50 of them. So we have a lot more scripts capable of doing work. So I'm going to run demo 4 now. Now you'll see that this one is, if I remember correctly, this one is going to be making some progress, but it is a little slow. But in the meantime, we can see that we're using a whole ton of CPU over here on the worker as before, but we're still not using very much on the web server. And I would like to make it through 1,000 requests before we kill this. I don't know if this will make it through the first 1,000 for as long as we're willing to wait. Oh, there we go. So we got 1,000. So multiply that by 10. That's how long it'll take for all of them. But we'll skip to the end and we'll look at our stats. So now we've got 22 requests per second. So we're doing a lot better than the previous demo where we only had one worker, because now we're able to split the work amongst multiple processes. So we're able to serve more requests.
How many workers do you have?
I have 50 running right now. So then I will, let me restart. I'm gonna restart the Gearman server just to empty out the queue, so that we don't have to go through all those 10,000 jobs. And then I'll move on to demo number. Before I move on to demo number 5, I realize I may have been going a little fast. Does anybody not understand how we got to this point, or what we're trying to achieve? Sure. Yeah. Yeah, of course. Okay, so the demo code for number 4 is exactly the same as number 3. I just have a separate file so that we can see it's demo number 4. I started all the workers using something called supervisor that I'll show you guys how that works later. But it was basically a configuration script that I had that I told it I need 50 of this particular process to be running. Go ahead and start it, and then supervisor is going to keep them running for me and everything. I'll show you guys that in detail after the rest of the demos.
Can you show the process tree for how many for the different workers?
As in, yeah.
Yes.
Yeah. So we've got all 50 of these. and it's just that script, php worker.php. Okay. Where was I? All right, so now demo 5 is the same as the ones before, but the chief difference here is that instead of doing the jobs in the foreground, we're going to be doing them in the background. Doing work in the background is not blocking, which means that once this request gets sent, it's going to move on to the next line. In this case, the next line is nothing, so the script is going to end. So the web server is going to be ready to serve traffic to the next user. Now, you'll see that the requests are completing a lot faster than before. On the website, our CPU usage is still good. We're in the 20s, so there's a lot more that this server can do. And over here, we're still at really high CPU on the worker, but that's okay for now. That's what we have the worker for. We have the worker to be doing all this work instead of having the web server do it. And if we go up here, we'll see that our requests per second and our time per request are almost the same as what we were getting in demo 1 when we weren't doing any expensive work, when we were just displaying that Bootstrap template. And the reason for that is because the web server is actually not doing any work. All it's doing is shipping off jobs to the worker and not even waiting for them to complete.
So it's not queuing,
It is queuing.
but
So
it's not
waiting.
long queue.
Well, actually, it is. I shouldn't have.
It's not synchronous.
Yeah, I shouldn't have cleared. Let me run this again so I can show you what I mean.
Yeah, so basically what it's doing is it connects, it sends the work to the worker, and it says, I don't care what you're going to do next. I'm done. That's what
So this is a little peek into the queue. The name of the queue is expensive, and I've got 50 workers connected. But look, it is a very long queue. I've got 4,000 jobs.
But they're doing it all at once.
Well, it's doing 50 of them at once because I've only got 50 workers running. But it's running those jobs, and see, we're up to 10,000. We're up to almost 10,000 now, and that's it. We're not going to be getting any more because the bench is done over here. But the worker is doing all this work, and meanwhile our web server is done. 0% CPU. It's ready to do more work. It's ready to serve more pages. So what we've done here is we've offloaded this work, and we've freed up our web server to serve traffic. Yes. Yeah, this here on the right is a different server. So this is not having any effect on this guy over here.
What was the CPU effect when you switched from one worker to 50?
The CPU effect on web was pretty much on here. The effect was the same. It was still at close to 100% because all the worker does is it.
In both cases, it was 100%.
Yeah, because so this is just for the sake of a demo, just to show that high CPU on your web server is not a good idea. But the reason that it was at 100% either time is because it's just going to sit in a tight loop for about 3 seconds and hog the CPU. If you were doing API requests, for example, while PHP is waiting for the API response to come back, like if you're using curl or something like that, there's going to be time for other workers on the server to do work. So you're not necessarily going to have 100% CPU usage. There will be some switching back and forth depending on your application.
you have to tune it to your application.
Right. And this is a very contrived example just to show, hey, if you do this on your web server, you're going to use a lot of CPU, so you probably want to do it somewhere else. Okay. So recap of what we discussed. The gist of what we just went over is that we don't want the web application to be doing expensive work if we can avoid it. In some cases, it's not avoidable. Maybe it's something that the user expects is going to be slow. For example, if you're uploading a large album somewhere, maybe you expect that it's going to be slow and you're okay with waiting for it. In other cases, maybe you're loading the homepage of your site and you want to display a widget with, let's say, the articles that have received the most comments. You don't want to go in your database and figure out and sort and rank all your articles on the fly, so you'll queue that job up, and when that's done, whatever cache you had that displayed that information will get refreshed, and then the next person to go to the site will see it, but in the meantime, everybody's still able to access the site. It's a great idea to run multiple workers to distribute work. If you have just one worker running, it's going to use all the CPU that it can, and it may not even need that much. If you have 10 or 20 or 30 or 40 workers running, whatever you're able to run on your server, you'll be able to distribute that work a lot better and get better throughput. You can do that using a program called Supervisor. This is a package that I'll show you an example of what the configuration for it looks like. So this gets installed on your Linux server that runs the worker, and what you're telling it is this is the command that I need to run, and I need this many processes. If I turn this into a 10 or a 500, it's going to start up all those processes for me. The nice thing about this is that it'll log all errors and all regular messages out to standard files that you define, and each worker is going to get its own log file. So if you know that there were problems, you're not going to get log messages from different workers mixed in with each other. They're all going to be separated. And you can also have this, number one, you can have it automatically start when you start up your server. So if you have to reboot your server for whatever reason, you'll know that your workers are going to start up. And the best part probably is that you can automatically restart your workers. So if there's a PHP error or there's a strange exception that gets thrown, worker will terminate, and then supervisor will say, oh, well, you only have 49 workers running and you told me that you need 50. It'll start up that 50th worker again for you. The supervisord.org has a lot of good information and examples on doing this, so if you're interested in that, I definitely recommend checking it out. We should use background jobs whenever possible. If it's information that is not critical, that it has to be available right away, offload it, let it happen later, and then let your user get on with whatever they were doing on your site. And you have to be smart about how you implement Gearman. Decide if it makes more sense to be foreground or background. Decide if you can run multiple workers and do that. Just simply by adding Gearman, like we saw in demo 3 and 4, just the fact that you're using Gearman is not going to make your website perform well. Even though we saved on CPU and all that, our site was still performing really badly. So earlier we saw the high CPU on the worker, and I mentioned that I'd talk about that later. It's not ideal, but CPU only paints a part of the picture. The purpose of your CPU is to do work. So if it's doing work, that's normal. What you run into problems with is if you have a very high load average on your servers. This blog link that I put here is a really good explanation of what load average means and how it works. A good way to think about load average is think about a bridge with only one lane of traffic. If the load average on your server is a 1, and the load average on the bridge is a 1, that means that it's at maximum capacity. Traffic is flowing through it, but there's no room for any more traffic, and if more cars try to get through, they're going to have to wait. If your load average is below 1, things are going nicely, and you can do more cars can drive across, you can do more work. If the load average is higher, then cars are waiting to get on the bridge. When cars are waiting to get on the bridge, it's not a big deal. It's kind of annoying, but when processes are waiting for CPU on your server, especially when there are a lot of processes waiting, that can create problems on the server and eventually bring it down.
Why is that?
Why is that? Well, I mean, so if your server has different processes running that do different things that keep it running, keep everything operating how it's supposed to operate. So if those critical processes are waiting for CPU, and
yeah.
Exactly. Yeah. Now, if we run into a situation like we had in this demo, where our worker server was doing work, but the load average was a little bit high, we can scale that out by adding more worker servers. So you could have your web servers. You can have a Gearman queue server that moves the jobs back and forth. And then you can have 5 or 6 or 7 worker servers running as many workers as you need on it to keep your load average low and distribute the work.
So like you could have duplicate worker servers.
Right. Well, more than one worker server doing the same work. Right, and that's very common if you have a situation where you have to handle a lot of throughput. if you're in that situation, you're doing that much work, that's good. You can probably afford to run a few more servers, but in many cases, depending on what exactly is being done and how much traffic your site generates, you could probably get away with one worker server, depending on what it is you're doing. Yeah, I covered that bullet point before I got here. Yeah, this was just a demo. A few sites are going to see 250 concurrent requests. Yours will probably be a lot more reasonable.
Is it recommended to use a virtual machine?
A lot of hosting right now is in the cloud, so they really are all virtual machines when you think about it, and you can definitely run your workers on the virtual machine. The worker doesn't know if it's on a bare metal server or if it's on a virtual machine. When all this fails, ask your sysadmin, say, hey, I'm running this, look, here's the load average, here's the CPU, here's the memory, does this make you angry? If your admin's not angry, then you're in good shape. So a few tricks, a couple things that got me as I was learning how to use this over the past year. If you can, there's a parameter called unique ID that I'll show you how it works here. So there's a third parameter that you can pass to the do background, do normal, etc., called unique ID. And as the name implies, it is an identifier for this particular job that's unique to this job. So no other different job is going to have the same ID. And what this does is it will make sure that only one instance of this job can be in the queue at one time. So I'll show you a quick demo of how that works. Can't seem to quit that, so start it up again. Okay, so just turn that off, because I don't want those other workers running. Okay, so this particular demo is a little interesting because I've got everything running in one script. So before, how we had one script for the web server and another one for the worker. This is actually all just in one script. So here I create my worker, and I create the client. I add the function that I'm listening to. I'm listening for foobar, and here I'm going to add 25 background jobs to do foobar. And then here's where I actually listen for the work. So this is going to go out to the Gearman queue server, and then it's just going to give it right back, and we're going to do the work. So if I run this, you see we've only got one foobar, even though I put 25 in the queue. If I get rid of this unique ID, then we have 25 of them. So the nice thing about this is, let's say that you have like I mentioned earlier, you have a widget on your home page that displays some stuff. Well, you're not only going to have one user go to your home page and nobody else. You're going to have multiple people coming to your page. So if every time somebody comes to that page, it triggers a message being sent to the queue for work to be done, that worker is going to compile those most commented articles or whatever it is you want to display multiple times. And most likely that information is not going to change from 1 second to the next, at least not at any degree that you care to display. So by using a unique ID, you guarantee that as long as there's a job in the queue, that's going to be the only job that's in the queue. You save yourself the effort of doing work multiple times for no reason. A caveat is that prioritization doesn't work intuitively, at least not how was intuitive to me. It only takes effect if the function name is the same, and I'll show you what I mean here. The function name is this part here where you add function foo or bar, and you can send jobs at different priorities. You can send jobs either in the foreground or in the background, and you can send them at low priority, normal, or high priority. Looking at this, you would think, all right, well, the job that has high priority is going to be handled before the job that has low priority because it's more important. So in this demo, I've done the same thing that I did in this unique ID demo, where I've got the same script that's adding the jobs to the queue and then servicing them. And I'm going to add a function called foo that just echoes foo and a bar that echoes bar. And I'm putting 25 low priority jobs into the queue, then one high priority job into the queue, and then finally I'm going to start lifting the work. So if I didn't already know what I knew about this, I would expect that I just added this high background job. I want this job to be serviced before all these low background jobs. But you'll find that if you run that, it's going to do those 25 low priority jobs first, and then it's going to do my high priority job last.
Is it because of its order?
It's not because of the order. It's well, yeah, it is because not specifically. The reason is because the function names are different. So the way Gearman works is that if you have a low priority and a high priority job with the same name, it'll do the high priority one first. But if these have different function names, then it's going to happen in the order that they come in. And unfortunately, most of the times you find out about that is in production, when you have high priority jobs that you expect to be serviced first, and they're backed up because all the low priority jobs are being done first. So the trick to this, and I think this happens because of the naming convention chosen, this function name. I don't think that's a good name. I like to think of it as a queue name, because if you think of a queue, it doesn't necessarily mean that only one function can service it. When you think of a queue, anything can service that queue. So if you look at this one instead of having a job foo and a job bar, I have just one job called foobar. And in the workload, I tell it the function that I want to run. So here, I'm adding 25 low background jobs to the foobar queue, telling it this is foo, and then I add one high background job telling it this is bar. And then when the function gets run, it's going to see which I actually wanted to do, and then it's going to display the output. So now if I run this instead, we're going to find that the high priority job was the one that got serviced first. And that's because Gearman saw that they were all coming in under the same queue, and it was able to prioritize them accordingly. Did that make sense? Did I go through that a little too quickly?
Yeah, you're right. That function does come.
Yeah.
You think that it is, you're running the function.
Right. Yeah. If you think of it as a queue name, you won't.
Makes total sense.
Right. The reason you use separate queues would be like if you have different workers that can only serve a certain type of jobs. So you don't want this worker to be listening to one general queue because it might end up with a job that it can't service. So you can split it up that way. But generally, I like to put all common stuff into the same queue and differentiate by adding an extra parameter that tells it this is what I want you to do.
So prioritize by queue. You have to be in the same queue to be
Right.
prioritized on.
Right. Think of it as a queue name. Don't think of it as a function name.
But literally, it's the same function name.
Right.
But it's doing different things.
Yeah. So before, when I had crop image and resize image, or let's say you have crop image, and let's say you also need to resize images. That's another thing that you want to do.
Call it an image.
So you can call the image queue, right? And then in that job, you say, okay, the function that I want to do is I want to resize the image or I want to crop the image, and then let the worker figure out which one to do. That way, let's say that cropping the image is more important. That's something that you want to have done quickly, and resizing is second, or vice versa.
You crop it and make it large.
Exactly. Yeah. And one last important thing to remember: the worker and the client do not talk directly to each other. It goes through the server. So what this should tell you is that you should keep the messages light. Don't give the Gearman job server a lot more work than it needs to do. So if you are I'd say that you have a job that's going to generate a lot of data that you eventually need to pass back to the user. Don't send that data back through the Gearman server. Put it in a database, put it somewhere on your file system, and send back a reference to it. Say, for example, go to the database and look at this ID. That'll have the data that I just processed. Or look in this directory for this file. That's where the data is. Don't send 100 or 200 megabytes of data back to the server, because then your server is gonna, your Gearman queue server is gonna have problems getting new messages in and out. Unit testing. Anybody familiar with unit testing? Anybody see my unit testing talk here? So, so normally when we test external resources, we don't want to actually connect to them, because tests are supposed to run fast and we want to eliminate external influences affecting our tests. So typically we use mocks. So in the case of a Gearman job, we create a mock of it. We tell it this function is going to call the method called function name, and I need you to return foobar, and so on and so forth. This look familiar to anybody? You guys have done any of this before? Yes, no, maybe? Okay, you have. So don't do that for Gearman. Reason being, that's a lot of code to copy and paste in every single test. Mock function name, mock workload, etc., and you're not really adding any value, and it's hard to read. What I like to do when I test stuff in the Gearman library is I like to create a stub for a Gearman job. So what this test class does is it just exposes the function name and the workload publicly, and then when I call function name and workload, I just return it. That's almost exactly what the actual Gearman job does. The only difference is that PHP doesn't give you an API for setting the function name or setting the workload. So you either have to mock it or do something like this, extend it and implement it yourself. If you do it this way, then you really only need to write 2 or 3 lines of code every time you want to test a Gearman job versus all that mocking code. And same thing goes for the worker and for all this other stuff. And you only need to create it once. You don't need to create this for every test. That's most of it. This, I need to update this link. The link on the front page is the correct one. I'll put this on the GitHub link.
I'm not giving you a star for that.
Whoops. I'll fix that right now. I know in some parts I went a little fast. Does anyone have any questions or anything that you want me to?
Very good.
Oh, yeah, thank you.
Easy to understand.
It's
Gee,
the same thing.
These
Just,
questions made it
15.9.
better.
There we go. All right, there, now it's correct. So, thank you.